Rapid airfield damage repair operations rely on the use of heavy equipment to remove damaged pavement, prepare craters for repair, and produce repair materials on site. Crater repair teams require large quantities of flowable fill for backfill operations and rapid set concrete for the capping process. The primary equipment used to produce these materials is a volumetric mixer. When mobilized, this machine produces a flowable fill or rapid set concrete mix used to repair airfield damage. In this lesson, you will learn how to properly use the volumetric mixer to produce flowable fill and rapid set concrete. You will also learn components of the volumetric mixer, available concrete mixtures, volumetric mixer operations, and cleaning and maintenance of the volumetric mixer. Let's get started. Volumetric mixers are used to produce concrete materials at a job site and are assigned to the crater repair team. The operator may be part of the backfill or capping crew, depending on the capping method. Plant mixed concrete is produced using a job mix formula based on the weight and proportions of the material. Volumetric mixers produce concrete based on the volume and proportions of the materials. Volumetric mixer requirements. This volumetric mixer is a trailer unit, towed by a prime mover. An additional requirement is a water truck or a dump truck with a water tank in the bed. The crew includes a telehandler to resupply the mixer's bin with super sacks of materials and a water truck operator to ensure the mixer's water tanks have a sufficient amount of water. This collaboration of personnel keeps the unit mobile and easily resupplied. Note: the U.S. Air Force currently has the Pro-All and Seaman-Tech volumetric mixers in its inventory. Both machines are designed to work exclusively with the radar materials, unlike other volumetric mixers fielded in the Air Force. Both mixers are functionally identical, but operationally different. The following are the components found on the left side of the Pro-All volumetric mixer. Let's take a moment to review them. Hydraulic oil reserve, engine, cover tarp and protective top, mixed water tank, pressure washer, engine control panel, extension chute, gate control, electrical control panel, hydraulic control panel. We will now look at components found on the right side of the Pro-All volumetric mixer. Transition chute, emergency clean out water, bag breakers, bin covers, mixer auger, water pump, mixing bowl, speed select gearbox, right side extension chute, auxiliary auger. Now let's take a look at components of the tow bar side of the Pro-All volumetric mixer. Toolbox, prime mover source air and electrical hookup, tow chains, trailer jack, manual crank, 120 volts AC receptacle, height adjustable lunette eye. Now that you've seen where the controls and indicators on the volumetric mixer are located, let's look at how concrete is produced using this equipment. Whether flowable fill or rapid set concrete is being produced, water is an essential element in batching concrete mixtures. Therefore, an adequate water supply must be maintained in order for the mixture to function properly. Water truck operators maintain water supplies in volumetric mixer water tanks. Water supplies can be kept in a designated water truck, a water trailer, or a water skid. Repair materials for operations include super sacks of flowable fill or rapid set concrete. They are delivered to the repair sites by the warehouse operations haul team and telehandler operators. Flowable fill is a medium strength material used underneath capping operations. Rapid set concrete functions as its name applies. It is used to create a rapidly setting, high strength surface. It has a design strength of 9,000 psi. Rapid set concrete has an initial set time of 45 minutes in fair weather. Initial set means that it can handle radar vehicles and equipment traffic. Set time for aircraft traffic of all airframes is 2 hours. In the radar process, citric acid is used as a retarder to slow the rate of hydration and counteract the effects of hot weather during the setting and curing process. This material is added during the mixing process if needed. In the radar process, aluminum sulfate is used as an accelerant to speed the rate of hydration and counteract the effects of cold weather during the setting and curing process. This material is added during the mixing process if needed. Now let's look at the pre-operational checks that need to be performed before the mixer can be pre-positioned or operated. Trailer connections. Ensure the trailer connection and air lines are secured to the prime mover. Check fluid levels. Ensure diesel fuel, engine fluids, and hydraulic levels are at the proper levels. Lubrication points. Ensure all grease fittings are properly lubricated. Catwalks. Ensure catwalks are down and secured on both sides. Hopper preparation. Retract the tarp, covering the unit, and then remove the hopper cover. Ensure bag breakers are properly installed and secured. Visually check the grizzlies inside the hopper are clear of obstructions. Tire and alarm check. Check tires for proper pressure. Inflate if needed. Panel removal left side. The cover behind the hydraulic control panel on the left side is removed for inspection of the conveyor chain sprockets. Pro-All doesn't specify a requirement for this action, but the Silverfax site at Tyndall encountered a failure at 65 hours, and because of this, students are instructed on how to remove the cover and inspect for material buildup. The cover is held in place by 3 bolts and can be removed with a ratchet and socket combination. Panel removal rear. The vertical panel on the rear of the material bin is removed to access the gears that raise and lower the gate. During normal operations, the gate control can become difficult to rotate due to material accumulation. Pro-All doesn't specify a requirement for this action, but it is helpful to remove this panel weekly. The horizontal panel covering the conveyor belt is removed to clear the area of material that is left after operation. This is done to preserve the rubber wear plates. Dry material remaining in the area could harden as environmental moisture is absorbed. Panel removal right side. The speed selector gearbox is removed to show the location of 5 hidden grease points that require servicing every 50 hours per the Pro-All lubrication chart. Operators must perform the following pre-startup checks before the mixer can be pre-positioned or operated. Pressure washer. Ensure the pressure washer rail is secured and the wand is serviceable. Start and check the mixer. Start the mixer and perform a functional check of the components: conveyor, auger, vibrators, chute, and gate controls. Water systems. Fill the water tanks on the mixer and perform a functional check of the water system. Auger system. Ensure that the spare auger system is secured to the front right side of the trailer and is in serviceable condition. Warehouse team. The warehouse team will deliver the repair materials to the volumetric mixer. Bags are delivered by a telehandler and open on a bag breaker, releasing material into the bin. Note: the warehouse team and water truck remains on call by the repair teams to deliver materials as needed to ensure continual operation of the mixer. Volumetric mixing operations. Start the engine of the mixer and lower the auger of the unit into operating position, around a 25-degree angle depending on the surface, and attach the auger chute. Open the auger pour panel and set the protective cover in place for the auger mixing bowl. The operator will then adjust the conveyor speed for the unit and set the material gate for a standard mix level. Next, the water pump will be engaged using the control lever in conjunction with the conveyor controls. The gear is set high for rapid set and low for flowable fill. At this point, the operator will engage the auger, allowing it to run up to speed. Following starting the auger, Disengage the water pump and begin to advance material down the conveyor. Stop once it is around 10 inches from the end of the conveyor. The water pump will be re-engaged and be allowed to wet the mixing bowl and running auger. Material will then be advanced and allowed to enter the mixing bowl to begin mixing concrete. The operator will then adjust the strike-off gate to achieve the desired concrete mix, which should have the appearance similar to that of a milkshake. In addition to periodic adjustments, operators should clean buildup of the concrete mix from the mixer to ensure it runs smoothly and does not become clogged or seize up the auger. The mixer is now producing concrete for the repair operations. Knowing how to operate the volumetric mixer is most important. However, there are a few important items you should keep in mind. Let's take a moment to review and understand them. Auger position. The proper auger position is based on the angle of the auger in relation to the ground. Under normal level circumstances, the position of the auger is set at 20 to 25 degrees. The auger mixing bowl will overflow if the auger angle is too steep. This optimal angle depends on where the mixer is positioned. The consistency of the concrete mix should resemble a gray milkshake, a runny slurry that pours easily and steadily. Environmental factors, including humidity, temperature, and mixture properties, affect this consistency. Operators control the mix consistency by adjusting the gate height, which alters the amount of mixed material that enters the conveyor and proceeds to the auger. Once you make an adjustment, you have to wait for the newly adjusted material to reach the end of the chute before making further adjustments. Mix buildup. Monitor materials in the auger mixing bowl during operations. If the material gets too high, then add water from your emergency water tank straight into the mixing bowl to prevent the material from getting too thick. Gate position. If the gate gets stuck during operations, use the spud bar to tap the gate while adjusting the gate controls to restore normal movement. Hopper vibrators. It is important to keep an eye on the amount of mixed material remaining in the hoppers. Operators should use the hopper vibrators once the material gets below the halfway point of the hopper bin. Premature vibrating can cause the material to pack tightly in the hopper and not fall properly onto the conveyor. Now let's look at using the volumetric mixer to produce material to backfill a repair or to create a concrete cap in radar operations. Rapid set concrete is used to create a strong, quick setting repair. During the capping process, the repair crews place the concrete mix across the repair to ensure an even placement. In fair weather, rapid set concrete has an initial set time of 45 minutes, meaning the cap can handle radar vehicles and equipment traffic. Set time for aircraft traffic of all airframes is 2 hours. Backfilling a repair provides a solid base to place a repair cap on. In backfilling operations, the volumetric mixer is used to create a flowable fill material. When backfilling for an asphalt cap, the fill operation is stopped approximately 4 inches from the runway surface. The flowable fill cures for 30 minutes prior to the placement of asphalt. Auger swap. In the event of mixed auger failure or material seizes the auger, the following steps should be followed for a successful auger swap. Since each mixer is shipped with an additional auger, ensure everyone is familiar with auger swap operation. Current recommendation is to be able to swap an auger in 30 minutes or less. Practice, practice, practice. Failed auger removal. Disconnect hydraulic, water lines, and electrical connectors from the control system. Lower the auger to horizontal position. Disconnect the electrical connector from the chute vibrator and remove the transition chute. Remove the rapid release ear by removing the pins and rotating the cam lever 90 degrees up and off the ear. Place the auger on the ground and remove the link pins disconnecting boom to auger. Leave the failed auger on the ground. Pull the unit forward to receive the auxiliary auger. Auxiliary auger removal. The auxiliary auger is stored on a single pivoting tube. Release the auger using the following procedures. A forklift is required. Release the ratchet straps securing the auger to the mixer trailer. Position forklift so the forks can be inserted into the slots of the lifting clamps. Pull the auger out from the machine until the pin clears the rear holding bracket. Lift the auger to clear the lip on the pivot tube. Remove the auger straight from the machine to clear the pivot tube. Once the unit is pulled forward, move forklift forward, placing the auger under the mixing bowl. Auger installation. Place auger on the ground. Back forklift out of slots on lifting clamps. Remove lifting clamps from auger. Lifting clamps can be installed on the failed auger for placement back on the pivoting tube. Insert link pins connecting boom to auger. Placing slight down force at the end of the auger, raise auger to horizontal position. Install rapid release ears, cam levers, and pins. Attach transition chute and electrical connector for vibrator to auger. Connect hydraulic, water lines, and electrical connectors to control system. Function check auger to ensure operational readiness. Volumetric mixer capping operations. The concrete capping operation can begin once the volumetric mixer is brought to the repair and the crews load repair materials, fill the water tank, and start the mixer. Operators must be sure to set the mixer for the proper material and water ratio, and then lower the auger into place. Once the chute has been attached, the mixer can begin to advance material and place concrete. Operators must remember to check the consistency of the mix regularly and adjust as needed. Following the direction of capping crew lead, the operator swings the auger to provide consistent coverage while the capping crew evenly distributes the concrete. Once finished, the capping crew signals the mixer operator to stop the auger. Finishing the cap. Several members of the capping crew assist the screed operator to ensure a flat repair. A screed is set at the edge of the repair and slowly dragged across the repair, smoothing the top layer of concrete and making it even with the edges of the existing surface. This is repeated as needed until the surface is properly finished. Once sufficient material is placed, the volumetric mixer proceeds to the next repair to begin capping operations again or off-site. Cleaning the volumetric mixer. The volumetric mixer should be cleaned and inspected after operations. In addition, a visual inspection should be performed after any repair. Any debris or buildup should be removed to ensure proper operation and to prevent damage to the mixer. All installations should have either a dedicated or temporary washout station established. Mixer operators are responsible for using the washout station to clean the mixer, since it's likely that they are most familiar with the equipment. To clean the mixer, the operator checks that all the repair material has been discharged, flushes the bin, quickly reports to the washout location so any remaining residue can be removed. The internal components of a volumetric mixer, like the mix auger and conveyor, are areas where concrete buildup often occurs. The volumetric mixer comes equipped with a pressure washer built in for cleaning the mixer during and after use. This assists in keeping material from building up inside the mixer components and causing it to fail during vital radar operations. The built-in pressure washer on the volumetric mixer runs off the emergency water tank. Take care when cleaning the auger on site to prevent the cleaning water from draining into the repair. Caution: for Pro All machines 2018 and older, the pressure washer cannot be engaged on the mixer while trying to adjust the position of the auger. This will cause the hydraulics to be overloaded and cause the mixer to shut itself off. This may have the consequence of locking up the auger and endangering the continued use of the mixer. Volumetric mixer maintenance. It's important to maintain the volumetric mixer in good working condition. Follow the manufacturer's manual for all preventive maintenance requirements. Volumetric mixer summary. Volumetric mixers are used to produce repair material for radar operations. This piece of equipment is a critical component of the radar process and is instrumental in allowing engineers to produce material quickly to meet completion timelines. Without the specialized equipment and rapid setting materials, repairs would be impossible to complete within the stringent guidelines established to resume airfield operations. We have provided the proper operating procedures for the volumetric mixer. To ensure mission success, the following are some actions to avoid. Paving lane widths should not exceed 11 feet to keep the repair manageable when using rapid setting concrete, and because the street in the tool trailer is only 12 feet long. The length of the form section should be no greater than 15 feet. Congratulations, you have completed the volumetric mixer lesson. In this lesson, you learned how to properly use the volumetric mixer, components of the volumetric mixer, available concrete mixtures, volumetric mixer operations, and cleaning and maintenance of the volumetric mixer. For the most current TTP and additional information, please visit the Air Force Civil Engineer Center Expeditionary Engineering SharePoint page.